Dear friends, welcome to the session on normal distribution. Whenever we are using any statistical technique, we need to first understand that we need to find out that whether our data is normally distributed or not. Why we need to check that the data is normally distributed or not? The idea is that a lot of statistical tests which are parametric in nature are based on certain assumptions about the distribution of data. So most of the tests assume that data has to be normally distributed. When we say that data has to be normally distributed, we mean that the mean, median and the mode are centrally located in the data and it forms a bell-shaped curve. But many a times we have seen when we collect primary data from various respondents that the data is not normally distributed or there are some issues or problems with the data. So before data analysis starts, we need to check that whether our data is suitable for the distribution of our data is suitable for application of any parametric test or not. In case the data is not normally distributed, we have good range of non-parametric tests available where the assumption of normal distribution or the distribution of data can take any form and then still we can do the analysis of results. The problem of normal distribution, if our data, the central limit theorem says that if our data is not normally distributed, so taking a large sample size will make the data normally distributed because of the huge sample size which we have taken. So all of us understand the mean and the standard deviation which describe the normal distribution. The mean is the central location, the peak, and the standard deviation is the dispersion or the spread of the normal distribution curve. Skewness and excess ketosis are 0 for a normally distributed curve. The null hypothesis which we try to test with normal distribution, whether the data is normally distributed or not, null hypothesis states that the population is normally distributed. To do this analysis, we will today discuss about SPSS. Before that, I would briefly talk about the kind of results which we are going to get in that. So we have Kolmogorov-Smirnov test. If the p-value of the Kolmogorov-Smirnov test is greater than 0.05, that means there is no statistically significant result. So the null hypothesis is not rejected or it is accepted and we assume that the data is normally distributed. Another important test which we would conduct today is Shapiro-Wilk test. This test also signifies that whether the data is normally distributed or not, and we check it with the help of the p-value. If the p-value is less than 0.05, then the distribution is statistically significantly different from normal distribution and the null hypothesis is rejected and the data is not normal. So then we need to go to non-parametric test to calculate our results. How do we check the normality? There are various ways how we can check it. One is Kolmogorov-Smirnov test, Shapiro-Wilk test. Then we can check it through the skewness and ketosis values. And the level of skewness and ketosis should be near to 0. Its level lies between -1 to +1. We assume it is okay. Now there are various ways how we can check through the skewness value. One method is that you multiply the standard error with 3. And if the skewness value is less than the standard error, then data is normal. Otherwise, it is not normal. Similarly, for ketosis also, we get the SPSS result where we have the statistic value as well as the standard error. So multiply the standard error with 3. If the ketosis statistic value is less than the standard error calculated value, then the data is normal, otherwise not. Another method of checking this is that we check it with the help of Z value. Now Z value takes the value from minus 1.96 to plus 1.96. So this Z value is calculated as the skewness statistic value divided by standard error of skewness. So this will give us a value which is the Z value. If the Z value lies between minus 1.96 to 1.96, so we say that our data is normally distributed. Otherwise, our data is not normally distributed. Third method of checking the normal distribution of curve is we look at the histograms. So with a small sample, the histogram is unlikely to be like a bell shape, but still we can try to see the approximate shape of the curve and find out that whether it is normally distributed or not. So something like this, a normally distributed sample would look like. You can see that near the mean value, so it is coming out as a bell-shaped curve. So usually it will never come as a perfect bell-shaped curve, but still the approximate shape we can understand is coming out to be like this. So when the data is skewed, we have to use a non-parametric test. So skewness would look like this. The curve would be unevenly shaped from one side. If it is moderately skewed, this kind of histogram we'll get. If it is uniform or there's no shape of any bell-shaped curve which is coming up, so we use a non-parametric test. Now, as we discussed, that Kolmogorov-Smirnov test significance value and the Shapiro-Wilk significance value. These two values should be greater than 0.05. If they are greater than 0.05, then the data is normally distributed. And out of the two tests, Shapiro-Wilk test is a more powerful test. We also look at the QQ plot, and this line. So majorly most of your data should lie on this line. If the data is going out of this line, so we assume that the data is not normally distributed, and there are outliers or there are values which are lying outside this centrally located line. Now let's do this with the help of SPSS. So I have a file where we have a list of 200 Nifty 200 companies, and they are classified as public sector companies and private sector companies, and their internet disclosure, how much information do they disclose on their website is given. So this score was calculated from a worksheet. Now we need to check the normal distribution of this data. So 0 is public and 1 shows the private sector company. Now we go to analyze. In the descriptive statistics, we go to explore. The classification of public sector companies or a private sector company is the factor. So we take it to the factor list. An internet disclosure score goes to the dependent list. So we will get the descriptives of the data. Then in the plots, we don't need stem and leaf, we need histograms, and we need normality plots with tests. Once we click on this, we click OK, and here are the results. Now you see the mean value is 64.93 for public sector and median value is 66. Trimmed mean is near to 64.83. Now we need to check the skewness and Ketosis value. So there are two methods. One is that you multiply the standard error with 3, the standard error 0.427, and see its relationship and check it with the statistic value of skewness. Or another way is that we calculate the calculate the z-score. So how this z-score will be calculated? So the numerator will be 0.125 divided by 0.427. So it comes out to be 0.292. Now if this value should be less than 1.96. So 0.292 is less than 1.96, this z value standard. So the data is normal, it looks like normal. Similarly, we can calculate the z value for the kurtosis. So it will be, the numerator will be 0.664 divided by 0.833. So it comes out to be 0.797, which is again less than 1.96 z-score value. So public sector companies' internet disclosure score looks like a normal distribution. Similarly, we need to check it for the private sector. Minus 0.104, that is numerator, divided by the skewness value of standard error, 0.186. So it comes out to be 0.559, which is again less than 1.96 value of z. So we say that the data is normally distributed based on the skewness of private sector companies. Similarly, we check it for the kurtosis. 0.570 divided by 0.370, it comes out to be 1.54, which is still less than 1.96 standard value of z. So the data is normally distributed. Now let's check the test of normality figures which we have got. Kolmogorov-Smirnov test, significance value we need to see for the public sector as well as private sector. It is greater than 0.05, which justifies that the data is normally distributed. So if the significance value of Shapiro-Wilk is greater than 0.05, so that means it is statistically not significant, and the data is, so we can conclude that the data is normally distributed. Now if you see the histograms for public and private sector, so it is like a bell-shaped curve, which looks like a bell-shaped curve, which is normally distributed, and for internet disclosure index as well. You can see here that the data is taking a shape of normal distribution. Checking the QQ plots. So most of the values lie on this line except for this value, but it is not causing much trouble. That's why rest of the values have come on this line. For internet disclosure index, you see all the values are lying on this line. So this is how we would check the normality of our data. And even box plot shows symmetry, which conveys that our data is normally distributed. Thank you so much.